In this video we are going to talk about the glycosidic bond. So all the disaccharide, oligosaccharide, polysaccharide are as a result of these glycosidic bonds. So let's look at the sucrose. Sucrose is the common table sugar, that's cane sugar and sugar beets, and it is formed by glucose and fructose. So this is alpha D glucopyranose, the first structure. And why it is alpha? Because because this this OH is facing down, so it is alpha. And why it is pyranose is because this O is here, this oxygen is here, that's why it is pyranose. So this is beta D fructofranose. Why it is beta? Because this OH is facing up, so that's why it is beta. Why it is franose, not pyranose? Because this O is here, this oxygen, so that's just it. So when we react this glucose and fructose, that's condensation reaction with removal of water, we have the sucrose. So the reaction is going to be with this OH, this removal of this OH and one hydrogen here, you get. So this structure, it is here, and this structure is here. So when we remove this hydrogen, that's just the glycosidic bond, COC. And the carbon number 1 here, this carbon is called the anomeric carbon. That's the carbon number 1 for aldosis. And for ketosis, the anomeric carbon is carbon number 2. This carbon that is forming the bond, that's carbon number 2, you get. So since the reaction is between the two anomeric carbon, then this is the non-reducing sugar, because it's actually the free anomeric carbon that would that would that would that would be that will give the reducing character. So in this case it is not free, so this sucrose is not reducing sugar. Let's look at the maltose. Maltose is formed by the alpha D glucose. I told you why it is alpha, because this OH is facing down, and then the alpha D pyranose, another form of glucose, sorry. So this is carbon number 1, this is carbon number what? Carbon number 4. So the reaction between this OH and this OH, removal of this OH and one hydrogen here will form the glycosidic bond. Why this? The name of this bond of sucrose is alpha 1 2. As you can see, this is carbon number 1, this is carbon number 2. So alpha, because this carbon number 1 is facing down, alpha, and this carbon number 2, the second anomeric carbon, is facing off, so this is beta glycosidic bond. But in this case they are both facing down, so we just said alpha D 1,4 glucopyranose, alpha D glucopyranose 1,4 alpha D glucopyranose again, and the name of the bond is alpha 1,4 glycosidic bond. So that's all for sucrose and the maltose. And you can go ahead by doing the structure of lactose. Yet that's by glucose and galactose. Thank you. And then I'll release a video on the glycosidic bond for polymers.